Good evening, everyone, and welcome to this 2 hours live masterclass on EMI and EMC for railways and metro. I welcome you all on behalf of Railway Academy. And for those who are not aware about Railway Academy, I'll start with a brief introduction about Railway Academy. Railway Academy is a railway and transportation sector focused training company based out of India. We operate from Delhi, and we conduct training programs across railway signaling, RAMs, functional safety, OHE, telecommunications, and many diverse areas around new and upcoming technologies in railway sector. So today, as part of our webinar series, we have organized a 2 hours masterclass on EMI and EMC, and we have with us Mr. Sreevasa Vasudevan. So I would like to welcome Mr. Sreevasa Vasudevan, who serves as an engineering consultant for safety, reliability, and EMC in railways. Considered as a problem solver in electronic hardware design, he's got diverse experience in automotive, medical, and railways. He has worked with Qatar Railways, Robert Bosch, and many reputed projects. So I would like to welcome Mr. Vasudevan to commence the session. Welcome, sir.
Thanks, Sumit. Thanks for your words. Yeah, let's start it.
So just one thing I'd like to share with the participants. So we will have a break at 8 p.m. of 2 to 3 minutes. And if you have any queries, please feel free to write it in the chat box. Mr. Vasudevan will pick up the relevant questions as per the topics that he's taking up during the presentation, and will answer it. We'll look at concluding the session around 8:45. 15 minutes we've allocated for question and answers, where we will pick up questions from the chat box, or also will unmute participants with whom we would like to engage into a conversations around the topic. So please follow the instructions properly to make this a good experience. Thank you so much. Please, Mr. Vasudevan, you may come.
Yeah. Thanks, Sumit. Thanks, Sumit, for setting up the decorum of the meeting. And yeah, let me just start with what we are going to do today. And I welcome all of you for this EMC assurance webinar, especially focused on railway and infrastructure. So what we are going to do today is to have a brief overview of a railway asset, because EMC is a topic which is not a standalone topic. It has to be a system integrated topic, and we have a railway as a complex system. So I will have a brief overview of the railway systems, and we'll cover through the need for EMC management, the standards we follow in the railway EMC assurance, the regulations we follow, and I will cover up with the basics of EMC, which will be essential for you guys to understand how to analyze an EMC issue, how to develop a product meeting the electromagnetic compliance, what are the basic terms of EMC in terms of electromagnetic asset. And I got a lot of questions in the registration time itself about what are the major sources and victim of EMC, and I will cover up as much as possible, because there are a lot of electromagnetic sources, and almost all of the electronic equipments are victims in the railway premises. So I will cover up at least some of them which are very relevant, very significant for EMC. Then we'll have a discussion on EMC assurance process, overall how the EMC is managed across the railway projects and products. What are the challenges we face in the EMC assurance area? And last couple of minutes, I will spend time to give a brief of a wider opportunity for EMC engineers in the railway sector, which is very crucial. We need a lot of EMC engineers in the railways, but we have very few. So if you have any questions, feel free to just put in the chat box. I'll try to read it as and when it goes.
Sumit, some people are not getting the audio.
Right. Okay. I think, sir, I'm getting the audio. So Hemant and Arun, could you please check your microphones, speakers or microphones, because we are getting it absolutely clear. Please check your settings at your end. Please continue, Mr. Vasudev.
Yeah. I would like to give a quick brief of myself. I'm having 12 plus years of experience in EMI EMC field. I started my career as an EMC engineer itself. I worked on multiple domains ranging from medical products, automotive, railways, and even defense products for last 12 years. And since the webinar is more focused on railways, I mostly spent time on Qatar Railways from 2015 to 2017 for a Doha Metro project as an EMC consultant, mainly for the infrastructure. And from 2018 to 2022, like the first month of 2022, I was in the UK working for multiple projects, ranging from network rail projects, which is the main railway contractor in the UK, and high-speed rail projects, HS1, HS2, and cross rail project, which is again a long-distance railway project in the UK, and act as a consultant for railway projects in Australia, mainly for Melbourne Metro Rail, Airport Link. In India, I worked for Chennai Metro Rail and Mumbai Metro Rail as a consultant for a couple of packages. And currently, I'm having a project in Malaysia Line LRT, Light Rail Line 3 as an EMC consultant as well. Yeah, that's it. Yeah, just to start with, railway is a complex system. Even though even the EMC standards define railways as a complex system, complex moving system, which has electromagnetic interference to a great significance. Why I'm talking more about different system? EMC is not a standalone discipline. It comes with interaction between multiple domains. And the railway has, we know that the signaling, telecoms, rolling stock, traction power, substations, station infrastructure. For example, if you see any of these disciplines, we have possibility for an electromagnetic interference. Even if you think of the station infrastructure, we have automatic fare collection system, which is again a radio operated device. And signaling, there are a lot of radio operated devices. Telecommunication, rolling stock has an onboard antenna, which is again EMC significant. Traction power operates on a high current and high voltage, which is a major contributor for magnetic field issues in the railways. Substation has transformers and very high voltage switching happening in the substation, which is again a EMC, a big EMC source in terms of compliance. And in railways, when we talk about railways have a long list of or a variety of types, like a long distance railways, metro rails, light rails, high speed rails, electrified rails. In electrified rails, we have AC electrified, DC electrified, non-electrified railways. So it's a vast topic where in each type of railways, the EMC or electromagnetics is relevant, even in the non-electrified railways, because we have signaling systems operating over the non-electrified railways. So EMC is significant over the breadth of railway systems from the very beginning itself. So to give an overview of signaling system and where the EMC is important, we have multiple intentional radiators in the signaling system. For example, CBTC uses 2.4 gigahertz intentional radiation, intentional electromagnetic frequency band. Global system for mobiles, especially for railways, operating in 876 megahertz. There are Euro balises for train detection and train protection, which operates on 27 megahertz. And there are multiple wayside equipments which are operating on a radio frequency range. And when you take an example of power supply system, which is a great contributor for electromagnetics in the low frequency range, we have substations which are receiving high power, high voltage from the main lines, and then switching it down to the low voltage, which is supplied for the train operation. The substations are a great source of magnetic field, and we have a requirement in the railways to keep the magnetic field below the limits as per international standards EN 50121. There are remote power monitoring systems running across the breadth of the railways, which can be affected by electromagnetic interference. There are power control centers, which are run by SCADA interface, which is again a communication line, which will be affected by electromagnetic interface. There are on the right hand side, I have shown a picture of railway pantograph and not a pantograph, the railway conductor, catenary and contact wires, which is again large conductors carrying long conductors carrying high voltage and high current, which is a source of magnetic field interference. The rails act as a return conductor where the whole of the rail current, at least in AC systems, this running rails act as a return channel, which is again a source of electromagnetic, mainly of magnetic field interference. And in terms of the traction current, you see a LRT going through a residential area. There are requirements to keep the magnetic field from the catenary to a defined level so that it will not affect the residential environment. It will not interfere with the human beings nearby, living nearby. We have international standards, limits, and regulations to keep all of the electrical and magnetic field levels below the limits. When it comes to communication or telecoms, again, there are a lot of intentional radiators like mobile networks, GSM connection, distributed power or wireless power control system, remote maintenance loco, and even though not falling under communication system, there are further systems which will be susceptible to the electromagnetic interference. For example, lighting system, station and passenger information system. So you name it, we have a lot of electronic devices working close together in the railway environment, which makes it very important that the railway systems should be considered for a system reliability. EMC can be considered as a part of wider system reliability, and because of the reliability requirements are too high in a railway sector, and the chances of safety hazards are too high, we have strict system assurance programs in place for the railways. For example, we have safety requirements, we have reliability requirements, we have EMC requirements, and all have international standards. For example, for safety, we have 61508 or EN 50128. For reliability, we have EN 50126 standards. And for EMC, we have EN 50121 standard. And a strict implementation of system assurance by standards, regulations, or following best industry practice is very important to achieve overall system performance. That's where the EMC as such a separate topic is of more importance. And for those who are very new to EMC, I'll give a definition of EMC or electromagnetic compatibility. It is the ability of an equipment or a system to function satisfactorily in the electromagnetic environment which is already existing environment, and without introducing any electromagnetic disturbance that will affect the normal operation of other equipments in the environment. So we are concerned about the emission from the device, which is the electromagnetic emission from the device. And we are also concerned with the immunity or the susceptibility of the device, so that our devices which are operating within the railway premises will not create electromagnetic radiation which will affect other equipments. At the same time, the equipments are prepared to withstand a certain level of electromagnetic radiation which are already existing in the railway environment. So EMC assurance overall is a process which we follow to take care of all the EMC effects which can happen during the operation of a railway system. So we follow EN 50121 as a major standard or a railway standard, European railway standard for compliance of electronic equipments used in the railway system. I will get through a brief. This picture is actually to showcase, what is meant by emission, what is meant by immunity for people who are very new to the electromagnetics. In layman point of view, emission is something which which the electromagnetic energy coming out of your device, and immunity is the capability of your device which to function satisfactorily in presence of electromagnetic radiation of the environment itself. So for any of the electromagnetic situation to happen, there is source, victim, and a coupling path. Source refers to the culprit or the system which is generating the noise or the electromagnetic energy. And the victim refers to a sensitive device which will be affected by the electromagnetic radiation. And the coupling path means, coupling method means the path through which the coupling happens from the source to the victim. I have shown a couple of examples here, like what can be a possible source of electromagnetic energy. It can be either natural sources, something like lightning. It can be an RF transmitter like a mobile phone. It can be an electric motor or a welding equipment which uses high switching current. And the victims can be any of the electronic device, for example, an RF receiver, electronic control boards, or video displays are possibly the biggest victims of electromagnetics. And the coupling path most refers to cables, antennas, ground connections, power lines, or a capacitive or parasitic inductance. So again, for the coupling path, there are three methods how the coupling can happen. It is either through a radiated coupling, or through conducted coupling, or through the inductive or capacitive coupling. I will show in more detail what the source, victim, and the coupling path looks like. A radiated scenario looks like a far-field situation when there is no physical connection between the source and the victim, still electromagnetic coupling happening. And a conducted scenario is where there is a hard connection or a hardware connection or conducted cables are available. The electromagnetic energy transfer from the source to the victim via conducted path. And there is a third coupling mechanism, which is called capacitive or inductive coupling, which is a near field scenario where there is no physical connection, but the cables are located very close to each other. This particular scenario is very common in terms of railways, where we have multiple cables routed across the railway line. For example, signaling cables are routed, telecommunication cables are routed along the railway line, where there is a high chance of inductive or capacitive coupling happening. So the electromagnetic energy transfers from the source to the victim via via coupling mechanism. And I can show you some examples in the railways, what can be referred to as the conducted, inductive, or the radiated coupling mechanism. First, I will come to the radiated coupling mechanism, which will be more easy to visualize. A radiated coupling mechanism can happen, for example, in terms of the pantograph, the railway pantograph, which is a connecting leg from rolling stock to the overhead catenary line. Due to the high speed movement of the rolling stock, there can be a arcing which will radiate electromagnetic energy or a magnetic field to nearby electronic components within the rolling stock. This is an example for the radiated coupling mechanism. There are conducted examples where a traction return current sharing the same path with the signaling current in the railway line or the track return itself. For inductive coupling mechanism, there can be an inductive coupling happening between the return conductors and the cables of the axle counter. I just want to take a feedback of you, whether you're getting the point, inducted, conducted, and radiated coupling mechanism. If you're getting the concept, please can you type in the chat box. Okay. Yeah, please explain radiated. So radiated is nothing but, I'll tell you an example of mobile phone, which is having a mobile communication, right? Where the electromagnetic energy reaches your mobile phone from an external tower via radiated traveling of the electromagnetic energy. Same like here, in this example, there is a electrical arc happening in the pantograph, which is a high voltage energy discharging to the environment or the nearby atmosphere, which will lead to kind of a lightning kind of a situation. Now, I'm not telling exactly it is lightning. It's kind of a high voltage discharge happening, which is an electromagnetic energy discharge capable of disturbing the electronics installed inside the railway or inside the train, the rolling stock. Is that clear? Radiated seems to be conductive in this case, not exactly. See here the source of radiation happened because of the arcing between the conductor and the pantograph, but the actual electromagnetic energy traveling from source to the victim is via radiated mechanism. A power transmission lines example of conduction in induction coupling path. The power transmission itself can be a possibility of a conducted noise itself, because power transmission lines have harmonic noises or switching noises because of the the conversion from the high voltage to low voltage. So power itself is a conductive mechanism, and inductive mechanism mostly because if you can see this example, where in AC railway system, the return current travels through the railway track itself, which means all of the current returns to the source or the substation via running rails. Imagine a axle counter installed on the railway on the railway track itself, and the cables of the axle counter running very close to the track. The magnetic field generated by the return current can couple with the cables of axle counter. This is called inductive coupling. Just give me a second. Let me just first clarify whether the guy Henry, are you clear about the radiator mechanism right now? Yes, yeah, Henry is clear. I will take questions one by one. Induction coupling is not due to electromagnetic waves, right? It is just because simply electromagnetic induction. Yeah, it is because of electromagnetic induction. That's the point here. It is the electromagnetic induction happens because of the electromagnetics itself. Yeah, it is similar to a transformer, exactly. This device confirmed the EN 501 is enough to be used, especially in railway, especially metro. If not, what other parameter standards? Yeah, I will come to the standard section. I have a slide on standard section. Yeah, sometimes most of the times 50121 is sufficient, but I will tell you specific standards required for products which are requiring the product standards. Or effect in axle counter. Yeah, I can tell you. See, axle counter is a sensing signal, right? It's a sensing system which will sense the location of the wheels of the rolling stock. So if we have a magnet, and what actually happening from the sensor, the position of the wheels are sensed, and it will travel back to the control center via the cables. So imagine a situation where, because of the electromagnetic interference, mainly due to the magnetic field interference, these cables carry noise. Now, consider that you may not be getting the right signals in the control center. That is one scenario where electromagnetic waves can or EMC issues can affect your system. EMI define EMC and EMI define current limitation by standard on sophrometric current. Yes, yeah. EMC and EMI difference. I'll just go back. Electromagnetic compatible EMC is the ability to ability to withstand both it's kind of a compatibility, like how will I say, okay, let's come to the EMI first. EMI means electromagnetic interference, which can be a noise generator from your device, or can be generated from the external device. So any electromagnetic energy which is creating a disturbance to the neighboring equipment, it is called as electromagnetic interference. And EMC, or electromagnetic compatibility, means that the equipment is capable to withstand any of the interference, one, and secondly, the system or the equipment itself is not creating any electromagnetic energy which will disturb other systems. So EMC is a two-step process. That is, compatibility is a two-step process. We need to ensure that our product is not creating any electromagnetic noise, as well as it is capable to withstand minimum amount of noise available in the environment. So that's EMC. EMI is electromagnetic interference, which is simply any noise generated by your device or neighboring device, or already existing in the nature due to natural factors like lightning, lightning or nuclear reactions. We have electromagnetic energy possibilities. Is that clear? Can I take EMC as immunity and EMI as emission? No, it's not possible, because EMI is electromagnetic interference, which can be taken as a emission in a way, and EMC is something which your device will be compatible, is not creating emission, as well as immune to the noise. So it's a two-step process, EMC. EMI is like a disease and EMI is a vaccine. It's a kind of good analogy. Yeah, let's just move to next slide. You can keep posting questions. I will take the questions as and when it comes. Okay, source victim coupling parts we covered. Okay. Yeah. Another area where electromagnetics or the EMC is concerned in terms of railway is the effect on human beings or the human health. So I don't know whether it's really proven that the mobile tower will create some health effects for human being. Staying near the transformers for a long time will create health effects. I don't know, but there are regulations to avoid such situations, or which will lead to health issues. For example, workers working on pantograph or the railway high voltage lines, they should be protected from electromagnetic fields, and general public should be protected from the electromagnetic energy which is produced by these devices, maybe the high voltage conductors we use in the railways or the signaling system we use in the railways. It should not create any harmful effect to the human being, be it workers or the public. So we have standards in place like electromagnetic fields work regulation 2016, EU Council recommendation 1999. So when you design the whole of the system, EMF or electromagnetic field levels is another parameter which needs to be taken into account. Yeah. And in terms of safety is a critical factor in the railways, and EMC issues can really lead to safety hazards as well. But the major EMC directive, which is EMC directive of 2014, is not concerned about the safety at all. And the EN 50121, which is a railway standard, it's not talking about the safety. That's why there is a process in place for railway projects to take care of safety related EMI issues or EMC issues. There are some regional standards like railway standard RIS 0725, which is applicable in the UK for safety of equipments used in the railways. And there are Network Rail, which is again a UK railway board, which defines the safety aspect of the equipments used in the railway. Yeah, since we now know about the electromagnetic issues or at least some of the electromagnetic problems which can come across in the railway system, how will we address it? There are standards in place, and more importantly, there are some engineering practice we follow. The reason being, the EMC standards are not design standards. It's basically the test standards. So you don't get a guideline on how to you don't get a standard which will tell you how to design an electronic equipment which will comply with EMC. No, there is no standard which is saying like that. We only have test standards. So once you design the product, you can test it and verify whether the limits or the levels are being meeting for the requirements or not. So that's why the standards come into place. So we have predominantly railway standards EN 50121 or EN 55022 as a standard for compliance. These are product or railway family standards. In the absence of product standards, we can use generic standards, 61006- series standards. Even in the absence of 61006-2 standards, we can use basic standards, 61004- series standards. The reason because the railway uses a multiple commercially off-the-shelf equipments, which are not especially designed for railways, but we can use those products in the railway after having an engineering verification, whether they're meeting the EMC requirements or not. And there are guidelines for cable management system, for example, 61005-2, even EN 50174 for cable routing inside the buildings and outside the buildings. And there are a couple of network rail standards applicable in the UK as well. So let me just take some of the questions here. How to calculate interface is generated is any equipment and how to minimize it. See, there is a mechanism how the railway will function. When you design a new railway or a new railway project is being constructed on a greenfield land, what we do is a site survey, which will ensure that what is the electromagnetic radiations existing in the environment. Like, is there an airport nearby, which is creating a radar frequency? Is there a radio station nearby, which is creating higher levels of electromagnetic energy? So we do a site survey to ensure that already electromagnetic interferences existing in the environment. That's one thing. But for an equipment, we need to go through an EMC testing in an EMC test lab to ensure that whether any electromagnetic noise is generated above the limit specified. How to minimize it? We need to do design, electronic circuit design, which will minimize the electromagnetic radiation. Second, installation practices. What next question? What devices are used to protect workers attending 25 kV traction system? So we don't have as such EMC protective equipments. We don't have. So we have specific specific clothes to be wear if a person is exposed to electromagnetic field for a prolonged time. Other than we don't have any equipments, or protective devices are not applicable for human beings. Okay. Is a walkie-talkie instrument in locomotive will affect onboard equipment? See, walkie-talkie is already equipments installed in the railway will be already tested for the levels. So an equipment or a walkie-talkie installed inside the railway will be already tested for the maximum radiation coming out, and the frequency operation of the walkie-talkie will be set in such a way that it will not interfere with other frequencies used in the railway on board, as well as the other equipments will not be affected. So we cannot 100% say it will not interfere, but by standard and by testing, it's already be ensured that walkie-talkie or any of the electronic radiation equipments will not create a disturbance nearby. And as EMC engineers or EMC responsible people in the project, they need to ensure that this interference will not happen. Induction effect of 25 kV OHC and 750 volt DC third rail. Yeah, I will come to that. It's again a long topic. I think we have one more slide on that. What is incident EMI? I didn't understand that in incident EMI. Can you tell about effective induction from 25 kV? Okay. What expel of signal strength maximum for signals on board? See, signal strength is something different. How the signal strength is not limited, or it's not an EMC topic. It's more or less the antenna topic. How much is the signal strength possible? Okay. What is the difference in EMI 11 1/25, 2/25? Okay. Yeah. Okay. See, So there are multiple configuration of overhead lines for various reasons, and one reason can be EMC effect. There is a difference in performance with respect to return rail, one return rail, or a 2x25 kV, and and there is more advanced systems like auto transformer system, which will be much more immune to much more less electromagnetic noise generating system. So there is a difference, but to quantify how much of the difference is a lot. No problem. Yeah, I'll just continue with the presentation. But any topic related to the slides which I am covering, we can discuss. For example, this particular slide is something which question previously asked. You know, what is the limitation of the standard or something like that? Yeah, what I was trying to explain here. EN 50121 is a standard which is being followed for railway. It doesn't ensure that all of the electronics installed in the railway system will be tested and certified, because the standard itself has some gap. For example, the frequency range covered by EN 50121 starts from 150 kilohertz to 6 gigahertz. So there are equipments which are operated at frequencies other than this frequency range. For example, track circuits, normal track circuits, which has operating frequency in terms of kilohertz, like 15 kilohertz, 20 kilohertz, 75 kilohertz. Different track circuits are there. Traction harmonic currents, which is again a multiple of 50 kilohertz or 16 kilohertz, 16 hertz or 50 hertz. The EMC EN 50121 standard does not cover it, and there is no answer for what will happen higher frequency, for example 5G communication or radar frequencies, which is coming in over 20 gigahertz. We don't have a clear answer on compliance standards covering those frequency range. As of now, these are addressed by a different mechanism called hazard analysis. I will cover on what is hazard analysis also in the slide. Yeah, maybe this is more clear right now. What is EMI, EMC, and EMS? Maybe this answer more or less. EMI is mostly in terms of emissions from the system. Electromagnetic stability talks about the immunity of the system. And EMC is a word which is used to represent both EMI and EMS. And the reason why we are actually concerned about implementing standards and implementing standards is because mostly in most of the countries, it is regulated by the laws. For example, in the UK, we have EMC regulation 2016, which makes it important that all the electronic equipments used in the railway should be at least complying with the EMC directive. All the radio equipment, which is the intentional radiators like the walkie-talkies you use, the signaling equipments you use, should be complying with a radio equipment directive, which again talks about the maximum power that can be generated, maximum radiation possible, spurious emission possible. Maybe this answers your question. Someone asked what is the maximum limit. So it varies depending on the product or the equipment which you are using, and it is being limited by a radio equipment directive standard. So I want to make it clear. See, there are two things to be taken care in the railway. One is the products, the railway product, that is the equipment that you use in the railways, where a standard compliance or complying to the standards of electronic products, either to the European standards or any local standards available outside the Europe, or if it is in the US, there are local standards available. These are important for the railway products. But how will you certify a railway project, something like a fixed installation, like a station, how will you ensure that the station is EMC compatible? How will you ensure that a substation is EMC compatible? How will you ensure that a depot of a particular railway line is compatible with the EMC requirements? So railway products are ensured for compliance by complying with the standards, product-based standards, and to ensure that the fixed installation, like station, substation, or depot, complies with the EMC requirement. We have something called EMC management plan, where we do a lot of EMC site surveys. We do hazard analysis, like like something like ensuring that there is no nearby airports, which is creating a lot of interference. There is no sensitive residential area which will be affected by the railway substation or the railway station itself. We will prepare an EMC test plan and test on site and ensure that the levels of electromagnetic radiation coming outside of the railway premises is within the acceptable levels. We produce EMC compliance metrics, which will ensure that all of the products used inside the station or substation or a depot complies with the relevant EMI standards, like EN 50121 or 61006 series standards. Also, there is a requirement to ensure the installation of the equipment within the station are done according to standards defined, like 61005-2, which makes sure that the cables are routed properly without creating any big interferences. Let's see some question. Yeah. During design stage, reports are being submitted for EMC management plan by consultant. Is there any way to cross-check it after completion of the installation during operation for metro system? Okay. During design stage, reports are being submitted for EMC management plan. Okay. Yes. See, EMC management plan is nothing but a specification document which will give instruction what all needs to be followed, what all standards to be followed, how the installation needs to be done. So compiling the product certification is only one part. During the end of installation phase, there will be a site survey, EMC site survey, which will ensure that the equipments are installed properly, following the manufacturer guidelines, arranging the cables in the prescribed format as in 61005-2 or EN 50174 standard, which has clear definition of how to route the cables, how to do earthing and bonding of the equipments. So it is pretty possible to ensure that the equipments are meeting the requirements, they are installed properly following the guidelines. And also there is a requirement which is transferred to the operation and maintenance manual, where EMC requirements will be taken care if you change an equipment, repair an equipment, or reinstall an equipment. Operation and maintenance manual will have the recommendation what needs to be done in terms of EMC. I think that's clear. Yes, you get this presentation slides. Sumit, that's correct, right?
Yes, it's right.
Yeah. Yeah, this is again a flow of standards, and it is particularly important because of functional safety. 61508 talks about different standards, and we follow EN 50121 only for EMC. That's not relevant. I think it's 7:52. Sumit, can we have a break now so that I will cover up the EMI sources after the break?
Yes.
Sure, we can have that break.
Yeah, if any question, one or two questions I will take while designing an overhead recording card having number of software inside it to sense it and record or chip, and how to ensure that design is EMC compliant. What is overhead recording card? I don't understand a recording card. Record overhead parameters, how to ensure that the design is compliant. So you need to test the recording card for EMC compliance in an EMC laboratory to ensure that the overhead recording card is not creating any electromagnetic noise which will disturb the rolling stock, as well as it will not be disturbed by the high magnetic field generated by overhead line. You need to test it in the lab and ensure it. It's not like you can ensure all in design. There are multiple guidelines which you can follow and ensure that you are following the best practices, but finally you need to test it in the lab and ensure that it is not getting affected or it is not generating noise, electromagnetic noise above the limits. Understood now. Yeah. So check the cable routing prior being approved. Yes, should the EMC engineer review and check the cable routing design prior? Yes, of course. EMC design, almost all the design and installation manuals should be reviewed, and also there is something called what is that? Construction document. I forgot the name of that document. It's not method statement. It is like what is that? I forgot that. It's called the construction design, which will be transferred for the construction. Yeah, I forget it. Let me give a couple of minutes. Give me a couple of minutes. Let me recollect it. Which can be useful for skill design purpose related to railway system. Not shop drawings. It is kind of a shop drawing, but it's not exactly shop drawings. As built drawings. Is there any specific tool which can be useful to be skilled on design purpose related railway system? So there are software tools which can be used to ensure your design is complying with the EMC requirements, not just for railways, for automotive or commercial or medical devices. The same tool can be used for railway systems as well. For example, for simulation software like ANSYS, CST, Microwave Studio, there are multiple simulation software which will simulate the design and ensure that you are doing a good design. Electric locomotive can be checked in lab for EMC compliance or only simulation? Yes, all the electric locomotive should undergo EMC testing inside the lab. It is more or less not inside the lab. Usually the equipments or the antennas will be brought to the factory and the test will be conducted in the factory. And almost all of the rolling stock which we see in use right now are tested for EMC compliance. Okay. So with that, we can take a 5 minutes break.
Yes, let's assemble at 8 p.m. Now that's 4 minutes. Please go ahead.
Yeah. Yeah. The next session and next topic is actually about the EMI sources. No, it is again a repetition of what we discussed already, but there are a lot of questions asked in the pre-webinar questionnaire regarding the different EMI sources to get the clarity how the interference will happen, what all things to be taken care in terms of EMC. So I thought to have a little bit detailed overview of what are the sources, possible sources, how to understand which equipments will create more of EMC issues. So we can classify sources into intentional electromagnetic energy sources and unintentional electromagnetic energy sources. And in the intentional category, as you know, the signaling equipments, which are anyway using electromagnetic energy for their data transfer, will come into place. Telecom equipments, which are either using transmission frequencies or GSMR or Wi-Fi systems in Wi-Fi based communication will come into place. Rolling stock equipments such as onboard radios are a source of intentional electromagnetic energy. There are communication devices inside the station. For example, someone was talking about walkie-talkie, or security guards will be using short-range communication devices, tetra frequency related equipments. So these are intentional sources of electromagnetic energy, and they can be an interference source as well. What we are more concerned about is the unintentional sources, like almost all of the electronic device which has some switching noise can be a source of electromagnetic interference. A large part of electromagnetic noise come from variable speed drives, which is used in escalators, lift, elevators, in the HVAC installed inside the station. Platform screen doors, which is using variable speed drives, and the pantograph arcing or overhead lines will be also a possible source of unintentional electromagnetic energy. And almost all the electronic device which has a kind of a display or a memory in it can be a possible electromagnetic victims. Yeah, I think we have gone through this scenario, where a practical scenario where an electromagnetic interference is happening. From the overhead line, there can be a magnetic field interference which will affect electronic equipments installed in the rolling stock. There can be a conducted current flowing from the overhead line to the railway for the rolling stock power conversion equipments, which will be affected by harmonics from the power supply directly itself, which is a conducted electromagnetic interference. And the same power electronic equipments from the rolling stock can affect other equipments installed on the track, for example, axle counters, balises, or track detection circuits, like that. So this is a summary of possible conducted and inductive electromagnetic interferences in a running rail. And I have taken a picture here just to give a view of how the severity of the possibilities of electromagnetic interferences inside a railway environment. So the railway systems can be affected by overhead power lines, which are operating at very high voltages and very high current values, which will have a magnetic field, which will have some magnetic field interfering with the equipments either in the rolling stock or the signaling equipments. That's one possibility. There can be external equipments, like external systems like radars installed near to the railway stations or railway lines, which will have electromagnetic energy. It's not magnetic, it's electromagnetic energy traveling from the radars, affecting the onboard electronics. There can be a high magnetic field from the rail contact wires. This is the rail contact wire. Because of the high current flow, there is a magnetic field induced, which will affect the onboard equipments or electronics. There can be a pantograph arcing, which we already discussed, and these same high current, high voltage conductors affecting the nearby signaling equipments. This is a typical scenario of a running railway, which will be affected by electromagnetic noise. Let's see how neutral sections affect EMC, does it increase EMI or decrease? Neutral section is not for EMC purpose, not only for EMC purpose. It actually what we are doing with the neutral section is to reduce the total length of the the AC conductors. The total length of the AC conductor is being reduced so that the magnetic field will not form on a larger extent, and it will go to the nearby premises. That's the one purpose for having neutral section. It will reduce the magnetic field. That is the purpose. Okay. What is minimum safe distance of railway system from high voltage power lines? Yeah. As such, 50 meter is the safe distance which we consider for high voltage power lines. Anything ranging from 20 meter to 50 meter is also accepted in some cases, but mostly 50 meter is the minimum safe distance considered for a greenfield new railway project. Okay, neutral section is in the OG is to separate supply of different phases. I don't know whether how this will support EMI. I don't know. I don't know. Hari Om Sharma. I don't know about that. Yeah, I think we already explained more detail of extra systems. Railways will be affected by equipment installed within the railway premises, as well as external interface. For example, the mobile towers, TV radio transmitters, airport radars, also with the equipments which are used in the nearby roads. For example, police or ambulance service will use their own frequency band, which can come in very close proximity with the railway system. There are security systems like X-ray machines, baggage scanning machines installed inside the railway station sometime, which can be again a source of interference. The station connectivity systems like Bluetooth, Wi-Fi devices. So there are a lot of electromagnetic noise or possibility of electromagnetic noise in the railway installation. Overhead power line, we already mentioned. ISM band equipments like simple equipments like vacuum cleaners, microwave oven installed maybe in a kiosk inside the railway station are also possible sources of electromagnetic noise. When things go wrong, when we do the presentation, always most of the questions sometimes what are the real life examples of EMC failures happened. So this is one classical example of IEP class 800 rolling stock, which was actually used in railways in the UK main line. And what happened is there is a line side audio or hum, which are interfering with the long axle counter cables. And this was identified only after installing or making the rolling stock running in the railways. Even though the rolling stock was tested for EMC levels, it was already tested. But there was an integration issue with respect to high-speed traveling of the rolling stock and creating a line-side hum affecting the axial counter cables. The manufacturer of the rolling stock was forced to go back and redesign their circuits, especially the power accepting circuits, like the pantograph and all, and was further required to qualify for the EMC testing again. Okay. Different traction subsystems are fed to different phases. So a neutral section is installed in AC traction. The EMI effect will remain same. I am trying to explain need of neutral section in. Yeah, Hari, what I'm telling is, I don't understand the concept of neutral section. See, there are limitation in terms of what would be the maximum distance that the power can be carried out from a substation. For AC systems, it ranges to 50 kilometers. For DC system, which is sometimes mostly the metro rails will run on DC systems, and not in India, but in some other countries like Sydney Metro works on a DC system. The maximum length of cable or the power can be transferred is limited less than 5 kilometers because the DC station won't have a capability to transfer for a long distance. And then suppose we have two substations connected one after the other. There will be a section where there is no connectivity between the contact wire. This is called a neutral section, mostly in railway terms, as I know. This is needed for isolating different substations so that the overall magnetic field will not be too huge. One reason, and second reason is it is a limitation of power transfer as well. Will mobile tower affect the houses nearby, or what should be the minimum distance between house and mobile tower? So as of now, we don't have clear studies available to substantiate that the mobile towers are creating radiation issues for nearby residential areas. I don't know. There is any minimum safe separation distance available also. What we have is the maximum power that can be transmitted from a mobile tower. This is limited. The maximum power that can be accepted and radiated from a mobile phone, this is also limited by standards. But I don't know whether there is a safe separation distance defined by the standards. I missed something. Also, please provide impact of EMI EMC on coaxial cable. Okay. See, any of the electromagnetic interferences falling on a normal copper cable, normal wire, will be picked up, and it will affect your system if it is a sensitive signaling cable or something like that. Coaxial cables are more immune to electromagnetic interference because of the fact that they have a metallic conductor inside the plastic sheet, which will act as a shield so that the electromagnetic interferences or the electromagnetic radiation will not get through directly. So we can say that a coaxial cable is much better than a normal copper cable without any shielding. But at the same time, it is not 100%. Even the coaxial cable can pick up noise as well if it is very high. Is there a mitigation measure if EMC survey results reveal some problems after completion of installation? It totally depends upon what is the problem. If an equipment is creating a problem, for example, a transformer is creating a more electromagnetic fields, yes, the solution or the mitigation measure is to replace the transformer. If the equipment or signaling equipment is creating a noise which is above the limits, we can ask the supplier to retest the equipment or redesign the equipment, bring back a new equipment which will have less electromagnetic emissions, kind of. Of course, after installation, there are instances where electromagnetic levels are high and redesign was required. There are many instances. What next? How to analyze EMI effect on quad cable. See, we have softwares available which can recreate the electromagnetic interference issues, which is affecting on a cable as well. There are specific software like from ANSYS, a cable suite available where we can simulate up from very low frequencies to at least 18 gigahertz. We can simulate effect of electromagnetic energy on the cables. Power field ranges that you can set of the traction normally yes, up to 50 kilometers you can go for AC. There are various faults appear in the onboard signal system where trained is neutral section. What can be done to reduce these failures? That's what I say. The concept of neutral section I am not clear, because as of my understanding, there is a area of area where the neutral section means there is no connectivity between one substation power to the another substation power, which is a very small area just for the pantographs to jump in. These failures support in that area, yeah. So that doesn't brings any particular benefit in terms of EMC. What it brings is it will reduce the overall magnetic field. That means it is actually reducing the impedance of the cables used. And based on that, in AC system, impedance is a big factor creating the electromagnetic radiations from the conductor. Okay. Yeah, another example which is class 442 rolling stock, which even though it was tested prior to installation, but after installing and using in the railway testing and commissioning phase, it understood it has an interference which is affecting the track circuits, and which required that the rolling stock needs to be modified so that the interference from the rolling stock will not affect the track circuits installed on the track. So these are real life examples. Both happened in the UK. Class 442 rolling stock is used in the UK. Class 800 as well as is used in the UK long distance railway lines. Yeah. So as I mentioned, a product EMC assurance is something which can be done at a equipment supplier level. I see many of you attending the webinar are working on products. So all of the electronic products shall EMC compliant, and there should be an evidence from the test in the form of test certificate from a laboratory tested for EMC. Installation of the electronics shall be done considering the worst case electromagnetic interface. Like the manufacturer will provide specific guidelines how to install a cable inside the rolling stock, inside a building, outside a building. There are guidelines available, and the standards like 61005-2, EN 50174-1 and -2. There are standards available which will ensure that the cables are properly separated and segregated. There's a great requirement of considering proper earthing of equipments which are having some electromagnetic shields, proper bonding of cables and cable trays, installation of cable trays. There are many requirements like that, which needs to be ensured at a product EMC assurance level. And the last part is to give an overview of what happens in a system EMC assurance, which we already discussed, where the first part is to define an EMC requirement, applicable EMC standards in terms of equipment compatibility for a human being exposure, following the EMC directive, etc. And the second part comes with the analysis of the electromagnetic environment, equipment EMC qualification, testing, checking the EMC certificate provided by the suppliers, conducting EMI hazard analysis. There are something which we cannot identify by complying with the standard. Like examples I given for what will happen above 6 gigahertz, what will happen less than 150 kilohertz. It is not covered in the EMC compliance standard. Therefore, we need to do a risk analysis. What is the risk for the particular project which we are doing? And the last part is the demonstration, which some of you are asking about. What will happen after installation, whether there is some mechanism. Yes, after installation, there is EMC inspection in all of the projects. There's an EMC auditing happening, and the post-construction site survey is a mandatory requirement for all the railway installation, like stations, substations, depot, etc. There is a post-construction site survey available. So this is the program which will follow for almost all of the railway projects. Yeah. And there are a lot of challenges in EMC assurance, particularly one because of the safety, which we already discussed, because there are many, at least a couple of frequencies outside the standard compliance. And there are safety hazards possible because of EMC issues. There is a interface of railway system with the third party. For example, the airport radars or the radio stations, which is already existing, or there are hospitals nearby which will be affected by the railways. So there is a interaction between the railway system and the third party system. There can be issues happening during the operation and maintenance phase. For example, somebody changed the installation of an equipment during the repair. He has not put the installation back in the proper state. It can be a problem for EMC assurance. And of course, there are cost impact and the demonstration issues. Yeah, maybe a couple of questions I will take. Yeah, I think I covered the technical part. Okay, let me finish fault EMI. There is okay. Fitness and PP slides also. Okay. Okay. Don't worry, all the slides will be shared to you. Is certificate for EMC engineer. So there are institute like INARTE. There is INARTE, which is a certified EMI EMC engineer certificate. Like you need to write an exam and to get qualified for INARTE certification. Which you ask Sumit. Sumit will write to me if you need any more details on INARTE certification. So what I have to share my experience just working for the railways for my last 6-7 years, and I have worked in multiple projects. I just want to highlight what are the opportunities available railway EMC engineers. So there are 15 metro rail projects running in India, and product companies like there are product companies which needs EMC engineers. There's a great requirement of EMC engineers in India. There are multiple rail projects happening in Middle East, like the project which I work with, Qatar Metro Rail, Doha Metro Rail project. Now projects are happening in Dubai. There is a new project of Metro Rail coming in Bahrain. There are projects in Egypt, but I'm sure many of you may not want to go to Egypt from India. It's a long distance. But there are many projects in the Middle East. UK, there is a lot of requirement for EMC engineers, and there are sponsorship visas available for this position, because in the UK, the EMC engineers are of a shortage, especially in the railways. So they are happy to provide sponsorship visas for them. There's a high demand of EMC and railway engineers in Australia, especially because of the Sydney and Melbourne rail projects currently happening. So there are a lot of opportunities for people who really want to explore more into EMC as a career in railways. Or I'm happy if you as a other systems engineer want to know more about EMC. Of course, it is relevant as well. There is no okay, so I was part of Doha Lusail tram. Yes, okay. I was part of Red Line and Gold Line as a consultant for Doha Metro. Yeah. So Sumit and the Railway Academy is coming up with a detailed course on EMI EMC, especially for railway. And see, compliance for EMC products for railway standard is a short part or a small part of the overall EMC activities in the railway. The major activity is EMC assurance of the project or the systems, or maybe station or depot, whatever it is. So we have a shortage of people who are really into EMC assurance activities, and the course which Railway Academy is bringing, which will cover the whole detailed process of EMC assurance, which will be followed based on UK EMC assurance process, which is Network Trail L2 RSC 30041. And the course will detail what are the duties of an EMC engineer and how to coordinate activities in the project, which will give you practical examples of how the EMC engineer works in the project. How to prepare an EMC management plan, what are the standards to be referenced, full details of how to. It's kind of a more like a on-job training kind of activities, expected to cover up. It's not an on-job training, but very detailed into how to produce the documents required for the EMC assurance, how to do the design review for EMC compliance, what needs to be evaluated, how to evaluate the compliance based on electromagnetic zoning, EMC zone principle, which is again defined in EN 50121 standard. And what is a hazard workshop, how to conduct a hazard. If you are an EMC engineer or a coordinator, how to conduct the hazard workshop, what all the templates to be used, how the risk ranking to be done for each of the hazard, how to prepare source, victim, applicable for the particular railway project. So this will be covered in a detailed course. And also, as I mentioned, there is need to have a compilation of EMC compliance evidence, which is a heavy activity or a very long project activity, which needs a lot of knowledge in terms of EMC assurance or EMC standards. So we will cover up how to prepare an EMC technical file, how to do an EMC compliance compilation of certificates. This will be a part of a detailed course, which Sumit will explain you or will give a brochure out after this meeting.
Yeah.
I think I'm done with the presentation. If you have any questions technical, I can answer for a couple of minutes.
Thank you, Sreevasa, sir. Thank you so much for this valuable presentation, and I can see a lot of people are congratulating you for this excellent presentation. So if you have participants, if you have any questions, we can take up questions. We still have got some time. So we are compiling the course. So in next coming weeks, we'll be sharing more details about it. The details would be available onto our LinkedIn page and our website. So if you could follow our LinkedIn page, it would be good. And you can also get notifications for future webinars, masterclasses, and trainings there. And so if you have any questions, please go ahead and we can take up some questions. I think, okay, LinkedIn profile, yes. So let me share his LinkedIn profile, and you can also connect with him directly. Yes, so I can share it right away. So all of you who'd like to connect with Mr. Vasudevan can follow his LinkedIn page and connect directly. So I'm posting it here, right there. So there is a question. Can you please explain EMC effects on 750 volt DC traction?
Yeah. See, whether it 750 volt or 1500 volt, the effects are almost similar, or like, you know, the major problem with the DC traction system is stray current effect, which will deteriorate the metallic equipments installed below under the railway premises. That's one issue. And second thing is that there will be loss of the total current, because if we don't have a proper concreted base, there will be a lot of stray current effects. Stray current effect is major in terms of DC traction and the magnetic field issues. When we have a 750 volt DC traction, or through a third rail or maybe a fourth rail, there is chances that the track circuits will get affected by magnetic field. These are the major issues with the DC traction, but DC traction is much more efficient in some other aspect as well.
How an EMC engineer will check and decide whether EM shield to be terminated at both end or at only one end, and what are the consequences of both cases?
Okay, show me that. How EMC will check and decide whether EM shield to be terminated at one end, both end. Okay, it's a big question, and a lot of things to be answered on that. But let me help you with something which I can do. Let me see whether I can help you on that or not. Let me see. Which I'll show an example from the latest project which I am doing right now. Maybe because I'll present you a table which will give a summary of that. If that helps you, let me try quickly. So this is a project which I'm doing for LRT3 Malaysia project. So I have summarized your question actually here. Let me see. This one, I think this will help you. If you can take a screenshot or of this will give detail how which one should be grounded on both ends, which should be grounded on one end, which should be grounded on both ends. You know, I have given an example of what type of cables should be done what. I think it's much better than I explained to you. Have you taken the screenshot for that? Okay, I think
I'm sure they would have.
Yeah. So what was the question? How can I check rolling stock like overhead recording car or track recording car? AC system, online, whether the machines are okay. So for testing overhead rolling stock, the rolling stock manufacturer has test tracks, which is already supplied with the 2 by 25 kV or 1 by 25 kV, whatever the system they are supposed to be running it. So they have their own test tracks available, just like automotive test tracks we have. The same way, the rolling stock also have test tracks. You can check some of the company rolling stock manufacturer like CUF is a rolling stock manufacturer. They have test track, which I have visited personally. Test track, you check in Google, you will get Spanish test track, something you will get it. So CUF, which I am very familiar, which I have visited the test tracks already.
Are there any other questions, participants? Okay, so I think, sir, there are no more questions, so we can conclude the session today. Okay, Mr. Surendra, RAMS itself is a separate course, and the Railway Academy has a specialized course on RAMS. You can check this on our website. There is a 30 hours course on RAMS where we've covered RAMS topics in details. So this EMI EMC training would not be having a very strong overlap with the RAMS. Okay, right. Thank you so much, everyone, for participating in this session. When there's a question, how EMI depends on frequency.
Okay. Because see, EMI or it totally depends upon frequency, right? So electromagnetic energy travels via particular frequency. See, maybe I can show you some of my other slides, which will explain more on frequency stuff. So what is electromagnetic radiation? It is again something falls on the spectrum category, right? And what we call electromagnetic is somewhere around the radio waves range, right? So it is already having an inherent property of frequency already. And then and how the electromagnetic radiation travels. It has an electric field and a magnetic field which are perpendicular to each other. And the magnetic field will generate an electric field, and electric field will in turn generate a magnetic field. This is how the profile of electromagnetic energy happening, and the transfer of this radiation is by a modulation at different frequencies. And the frequency is important. Like frequency will determine how much distance it can travel. Frequency and of course power also factor. What will be the characteristics of the that electromagnetic energy defined by the frequency. So an antenna property works based on frequency. Any electromagnetic energy you receive on an antenna, it is because of a tuned frequency. So almost all of the electromagnetic energy we talk about, either radiated coupling or conductor coupling, it has an inbuilt frequency inside it. And with respect to frequency only, we can evaluate the electromagnetic energy. Yeah, we can work on a detailed session on electromagnetics. You know that's again a long session.
Sure, sir. We can plan that in coming weeks for sure. Yeah, right. So let us conclude the session today, and I would like to thank our master trainer, Mr. Vasudevan, for delivering an excellent presentation today. And as you can see, sir, there are a lot of people who are thanking you for this excellent presentation, and I'm sure a lot of people would be connecting you on your LinkedIn profile as well. So me and Mr. Vasudevan would be working on planning a detailed course on EMI EMC, and we plan to launch this in next 4 weeks. So if you have any suggestions for us, inputs for us to incorporate in this detailed course program, you're most welcome. Please contact us through our LinkedIn page, our email IDs, and we'll be more than happy to work on them. thank you so much, everyone, for joining this session, and have a great evening ahead. Thank you, sir. Thank you, Mr. Vasudevan, for your time. Thank you.
Thanks all. Have a good evening.
Thank you. Thank you.